Okay, so let's do a few more examples of um, populating a function like we did, but this time we're going to include the algebra of functions. Okay, so let's take two functions. G of x equals 6x plus 1. And let's take a second function, h of x equals x squared plus 2. Okay, now let's find g times h of x, okay, using the algebra of functions. Now here is the algebra of functions, and when asked to use the algebra of functions, I expect the student to show me this next step. If I want to find that equals g of x times h of x, okay? This is the algebra of functions. Now what we need to do is take g of x and multiply it by h of x. So this equals 6x plus 1 times x squared plus 2. And of course that equals 6x cubed plus 12x plus x squared plus 2, putting it in a more readable format with the higher powers first. That equals 6x cubed plus x squared plus 12x plus 2. Okay? Now let's assume, however, we wanted to find g times h of x plus 1. Well, then we're going to combine populating the function that we did before using a different expression with the algebra of functions, okay? So if we wanted to find this, then that would equal g of x plus 1 times h of x plus 1, okay? So what is g of x plus 1? G of x plus 1 equals 6 times x plus 1 plus 1. That equals 6x plus 7 plus 1, which equals 6x plus 8. H of x plus 1 equals x plus 1 squared plus 2. This equals x squared plus 2x plus 1 plus 2, which is 3. Now we're going to multiply the two together. That gives me 6x plus 8. Okay, so that's g of x plus 1. This is h of x plus 1, which is x squared plus 2x plus 3. So then g times h of x plus 1 equals 6x cubed plus 12x squared plus 18x plus 8x squared plus 16x plus 24. Simplifying, we get 6x cubed, that takes care of that, plus 20x squared plus, what is that, 34? Yeah, 34. 34x plus 24. And that is g times h of x plus 1. So there we not only used the algebra of functions, but we also populated the function with a different expression like we did before. Let's do something even more complicated. Let's combine populating a function with a different expression and the algebra of functions and changing the variable. So, given g of x equal to 3x squared plus x plus 1/2, plus 1/2, and h of x equal to 6 divided by x plus 1. Okay. Find g plus h of t squared. Now, using the algebra of functions, this is equivalent to g of t squared plus h of t squared. So what is g of t squared? It equals 3t squared squared. Now recognize what I did here. I'm replacing a t squared for every x, but that x is also squared. Okay, so that's 3x squared. It's just that x is t squared plus t squared plus 1/2. So this equals 3t to the 4th plus t squared plus 1/2. Okay, what is h of t squared? Well, that equals 6 divided by t squared plus 1. Adding these two together, so g plus h of t squared equals this plus that, 3t to the 4th plus t squared plus 1/2 plus 6 over t squared plus 1. Okay, now this isn't simplified. We need to go ahead and cross multiply through. Okay, so what do we get? We get 3t to the 4th times t squared plus 1 plus t squared times t squared plus 1 plus 1 times t squared plus 1 plus 6. All that is going to be over the common denominator of t squared plus 1. Sorry, I had a itch on my eye. I had a scratch. So anyway, so now we need to distribute through, combine, and simplify. That gives us 3t to the 6th plus 3t to the 4th plus t to the 4th plus t squared plus t squared plus 1 plus 6 divided by t squared plus 1. So combining like terms, we get 3t to the 6th plus 4t to the 4th plus 2t plus 7 divided by t squared plus 1. And that is the final answer. That is g plus h of t squared. So we've just combined everything we've learned now in that one example.